Okay, today we're going to learn how to solve a system of equations by using the graphing method. And our system is going to be in slope-intercept form. Okay, so again, we've got a system of equations, so we've got more than one equation. And we're trying to find the solution to this. So let's graph these first, and then we'll kind of talk about what that means. Okay, so I'm going to graph the first one in pink, and notice that these are already in the y equals mx plus b form. So we know how to graph those. If not, check an earlier video. We'll start here with our y-intercept of 3. 1, 2, 3. 0, 3. And then our slope's 1 over 2. So remember, slope was your difference in y over your difference in x. So go up 1 over 2. Keep following that form. Or we could just kind of down 1 over 2. Okay, obtain that line there. Now I'm going to graph the next line in blue. Okay, go up 1. Boom. Slope is 3 over 2. Difference in y over your difference in x. So up 3. 1, 2, 3. Over 2. 1, 2, 3. Over 2. Oops. Terrible. Okay. So I see I graphed my two lines, and I notice this is absolutely ugly. But there you go. And I notice that my two lines intersect at this guy right here. The coordinates on that guy, 2, 4. So our answer here is 2, 4, this ordered pair. So x equals 2, y equals 4. But you're probably asking a great question. Mr. Pons, what does that mean? Good question. This ordered pair right here is the only ordered pair in the entire world that works for both of these at the same time. So if we were to substitute 2, 4 in, this would be true, and at the same time, that would be true as well. Feel free to take a second, do it by yourself. Substitute 2 in for x, 4 in for y, and you'll see that they both come out to be true statements. It's the only ordered pair that works for both of them. So that's something to keep in mind as you move on through the system of equations from now until the end of your math life. Whenever you have a system of equations, you're looking for that intersection point of however many equations that you have. Whether it's 2, 50, 60, I don't care. But that's something to keep in mind. You're looking for that intersection point. And this is the only ordered pair that works for both of them. Okay, let's try one more example here. Okay. Okay. My next example, we'll have y equals negative 5/4 x minus 3, and y equals negative 5/4 x plus 4. Okay. I guess I should have wrote that one a different color. Who cares? Okay, first one I'm going to graph will be in pink. Y-intercept is negative 3, 0, negative 3. Okay, now you have a slope of negative 5/4. So remember, you throw the negative sign with one of them. So it's either negative 5 or they're the same exact thing. They're both not negative because then it'd be a positive number. If I use the first one, if I go down 5, 1, 2, 3, and I don't have any little tally marks, so I'm going to use the second one. Remember, they give me the same answer. 1, 2, 3, 4, 5, my difference in y. 1, 2, 3, 4, my difference in x. I'm going to graph those two. Okay. And if you're struggling with graphing the slope like that, look at an earlier video. You don't want that to be killing you on these problems. Okay, looking at the next one, I'm going to graph in blue. 1, 2, 3, 4. My slope is again -5/4. This time I'm going to use this one instead, because if I go up 5, I go off the screen. So 1, 2, 3, 4, 5. Down 5/4. 1, 2, 3, 4. Graph these. Okay. Now if you look at these two lines, you notice that they don't cross. They don't intersect. Okay? You could have also noticed that from the beginning. When lines have the same slope and different y-intercepts, they're parallel lines, but okay. So we see that we don't have any intersection points here. So if we think about our last example, we were looking for the intersection point, because that's the one that works for both of them, the ordered pair that works for both. Since these don't have any intersection points here, there's not going to be an ordered pair that makes both of these true at the same time. So our answer here would be no solution. And that again is because there's no ordered pair that works for the blue and at the same time works for the pink. Okay? Whereas in the previous example, you had where they intersected. So I guess best way to attack these, graph them, look for that intersection point, and after you figure that out, make sure you understand what the intersection point tells us. Here, it didn't have any, so there'd be no solutions. If they both turn out to be the same line, they're intersecting at pretty much every single point on that line. So in that case, you would have an infinite amount of solutions. Okay? Thank you very much.